This is my first time in Singapore and my first time in Southeast Asia. So I'm kind of excited. You have like so many good plants. I love it. And wildlife's pretty good. I'm like used to coyotes and little trash pandas in my backyard, but you have like lizards, which is really cool. Yeah, way better than coyotes. All right, so I'm going to talk about storytelling, and I'm going to talk about using performance observers to do that. So hello, 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 hello. I'm Irina. Hello. I am a developer. You can find me on GitHub. I do code for work, and sometimes I maintain a few projects here and there. I write up a few projects here and there in my spare time. But in other parts of my time, I like to draw. And so sometimes I draw like random stuff, but sometimes I draw what I like to call computer art. So it's like little guides that I've put together on several things that are interesting in the computer world, like things on streams or working with async hooks or how V8 works. And so today's talk is going to be a little bit like that, but in a talk format. So I've tried to like kind of build a narrative around using performance observers and how we can use those as narrative in our own applications. I also like ramen, so there's a few pictures of ramen. I hope you like ramen too. I eat a lot of ramen. I had like 11 bowls of ramen for the 13 days I was in Japan in December. It was pretty great. So hello. Storytelling, performance observers. Like I said, we're going to try to build a little bit of a narrative as to how we can build out applications and know a little bit more about them as we work in our Node process. So mostly I'll be talking about Node, but there might be some kind of browser references to that as well. So why are we even here? Like, why do we want to kind of find out more about our applications? I think that comes down to the fact that we need to have more knowledge as to what's going on. We want to know when a request comes in and what happens after that. And how long does it take for us to look up a thing in the database? How long does it take us to do a put in the database? What's the difference between writing to the database versus writing to Redis? And these kinds of metrics, we kind of want to know it all, and sometimes it's hard in your processes. But we want to know the numbers anyway. And numbers are pretty important, so that's kind of the thing. Like we want to know the numbers because numbers gets us places, and then we can either improve or I don't know if we want to not improve, or stay the same in terms of how we build stuff out. So numbers are pretty important. But where numbers takes us is, to kind of keep on with a theme of storytelling and having a narrative. A lot of the times what we'll do to get some sort of story or some sort of tracking in our applications is having loggers. So there's one like, in Node, there's a Pina logger that gets us a little bit of information about what happens in our application. We put that together with our server, and we get some data out so we can see how long something takes. We can probably get a little bit more from the process ID, and we kind of can use that information to our advantage and kind of build out that narrative. So loggers are great, but we want to kind of go from numbers, and we want to be able to track some sort of information from there, right? We don't want to just have numbers that are unrelated to each other, so we want to go from numbers to tracking, and eventually maybe go to something like tracing to be able to actually build a proper narrative about our application. So tracing. What is tracing? Tracing, turn and face the strange. I wasn't listening to Bowie when I was putting this together, but I don't know. This kind of came to mind. So opentracing.io is a pretty good source or a pretty good kind of metric, or sorry, not metric, the word I'm looking for, a standard. So they've put together kind of a thing about what tracing does. So tracing tells you a story of a transaction. So tracing is a lot about what a workflow does and what a transaction does in your system. And you want to be able to kind of propagate it through a system and see what it is that you come up with. So eventually, you basically have like a single parent. And a single parent has bunch of children that it spins up, like different processes that start off with a single parent. Those children can have other children, and so eventually you kind of build out this tree. So the way to think about it is that, for example, you have a play in 4 parts. The play itself is a trace or a parent, and then the 4 parts are like the spans, and like the acts in the 4 parts are the spans, and things like that. So it's kind of like your story, but in a more technical point of view. And so, like I said before, a trace is useful to put together a transaction. Right, so a transaction is something like a request. So putting together a history of a request will build a trace of the said request. So if we were to look at something like this, we are then able to say that, okay, our entire trace is this, and then its little spans is an actual post request. And then from that post request, we want to authenticate the user. We want to, from that post request, get the data, save it to Redis, but we also wanted to save it to the database, so these are the 2 spans that can work at the same time. And then part of that is we want to send back some sort of message to the user, and so that entire thing makes up the trace, and these different transactions kind of put together in there. And so that, I talked about tracing, but then I want to go back to the performance timeline and the performance API. So it's interesting to know the narrative, and tracing kind of helps us build that narrative about what it is that's going on. But I wanted to look into the performance timeline and the performance API and see what kind of information I can get from using that kind of thing. So what happened is that performance timeline kind of got put together by the W3C, and that spec got implemented in both the browser and Node. So window.performance, most browsers now support this. You're able to kind of get whatever the information you need on timing and navigation in window.performance. The equivalent to that is require perf hooks in Node greater than 8.5. So then you're kind of getting the same thing by requiring perf hooks and having the performance object there, so also timings and node origin and that kind of thing. So perf hooks is the establishment of what an application timeline is. So what is an application timeline? So essentially, it is a timeline. So a request or a trace of the request, like we were talking about the trace. So kind of the same thing, request, you start off with that, and the things that happen throughout that and the things you can measure go together in an application timeline. So in a case of browser, you're kind of looking at a few different things. You're looking at when the resource loads, you're looking at the pain time. You might be looking at the navigation. So these are the kind of things that go inside the performance timeline. So let's actually dig a little bit deeper. So require perf hooks. Let's look into it. So we're able to get a few things from .performance on perf hooks. And it's the access to mark and measure. So what are these mark and measure things? Well, the easiest way to go about it is actually like digging through the API. So when you want to get something to be marked or measured within your performance timeline, you basically want to find out how long something takes to load, or how long a process takes to run, or like if you're running a loop, like how long does it take you to get through the entire loop kind of thing. So what you'll start off with is you mark a start point in your timeline, and in your application. You mark an endpoint in your application, and then you are able to run a .measure on it and see how long that piece of code takes to run. You're then able to get entries from it and seeing what exactly that particular entry looks like. Its start time, its duration, what type it is. And then afterwards, you got to clear it, like erase it altogether, so it's not part of your timeline anymore. So what it looks like code-wise is like this. So for example, we have a simple post request that we're trying to make. We're parsing the data, we're writing into the database, and then what we want to do is we want to set a mark in the beginning of that post request just to see how long the put actually takes. How long does it take us to spit the data back out to our client? What you're then able to do is mark an end within that put. And you're then able to measure it out from start to end. So something like this. And then once you're able to get the entries of that particular start to end measurement out, you're able to print it off and see how long something like that takes. So this is an example that I wrote. I'm making a ramen database for myself so I can know all the good ramen shops and remember them, because at this point I went to too many and I don't remember. So I heard Keisuke is good in Singapore. Somebody tell me otherwise, or like tell me a different one. So you get the performance entry out, and it's got the name, the entry type, the start time, and the duration. So you're able to work with that and see how long something like that takes. Cool. And this is, again, like to zoom in, this is what the entry object looks like. Name, entry type, start time, and how long it actually takes. Really useful for debugging. So let's actually zoom in into that performance entry. So we started off by saying we have a timeline, we have certain entries inside that timeline, certain things that need to load. But let's look at the performance buffer. So performance buffer is where we put all of the entries in. So every time we do a mark, like we did in the example, in Node, every time there's a garbage collection entry or a function entry or a node entry, these kinds of things, they all go into the performance buffer. So there's like a used up space and unused up space, which means, and the thing about the buffer itself is that there's only 150 entries you can have in there, which means you got to clear them. So when I was mentioning previously, like we got to clear at the end of the mark and the measure, it's because the buffer fills up and then we get memory leaks. So you kind of want to make sure the buffer is consistently cleared. And so there's a few different types of them. Node has different ones in the browser, so I'm going to do the comparison here. So Node has mark and measure, Node, garbage collection function, and HTTP2 for now. Maybe there will be more once a few more pull requests come in, kind of thing. And the browser also does the paint events and the frames and navigation and resources. Cool, but like I said previously, this buffer only has 150 entries, so we've got to be able to clear it as we go. So you clear that out by just calling .clear, and to like give you an example of what it looks like, is just clear marks and clear measures and clear functions are the ones that are present in Node. So if we were to clear it and then call measure again, we'll basically throw Cool. So you clear the buffer there. But the thing about this is like, okay, we're kind of marking these as we go along as we're debugging the application, or we're trying to establish like some differences between writing to Redis and writing to the database, for example. But we need to be able to keep track of these. So a good way to look at this is using the performance observers. So what are performance observers? What are we observing, really? So a performance observer is just an instance that takes a callback that works with the list of the performance entries, so the ones we talked about previously, and the observer object. So essentially, in your application, you go through certain entries, so like the marks and the measures that we were doing in the above example, and some stuff that Node gives you as is like garbage collection events. Obviously, you don't specifically mark them. And all those entries go into the observers list. So all of them just kind of keep on piling up in there. And then what you're able to do with that list is actually get some information out of there. So a good example of that is, so this is how you would set it up, right? Like, have a few entry types you want to monitor and you want your observer to work with. Function, measure, I kind of just put them all together. And then what you do is say, okay, I'm going to buffer them as well, so they all come in like async. And then once I launch my application, I get the garbage collection events, and then the ones that I've marked previously to kind of get there. And I'm actually probably just going to show you what I did because the code sample was kind of small. All right. How's the font size on that? Is that OK? All right. So I worked with the entry types. And then what my server did, so I just set up like a basic server. What I set up in my server is I marked a few events. So one here. And then I just put one in a loop, so it like runs through. And afterwards, I clear the marks. And what my handler does is just it looks at the entries that come back. So then if we were to launch the server, we'll get the 2 garbage collection events, and then we'll get the actual marks that we are watching for. And they all come back in this like nice list that you can then work with and log out and maybe do more information with it. Ooh. Now I wanted to I just switched to Tmax, so I'm like, my fingers are used to my previous bindings, and I keep pressing the previous bindings, and they don't work. Muscle memory, am I right? So I'm going to run start, and then I'm just going to curl because, oh no. This wasn't even like a demo. I'm already sucking at this. So I'm going to actually run Node example.js because that was a different thing. So I get the 2 performance entries for the garbage collection. 2. And then I'm going to run my little soft serve on 8080. And then I get all the other marks that I've put in there. Cool, so we get these like objects all in one convenient spot, and we can monitor them through the performance observer in our applications, which is great. So I just like these 2 modules I wanted to introduce you to. So they used to only have, because the performance API is available in both the browser and the server, these 2 worked with just the browsers. APIs, and I just patched them. So they both now work with Node and make it a little bit easier. So instead of you having to set up the entire observer, kind of just on performance does the observing for you, and on timing handles the timing entries, which were the first things we talked about. So it's kind of easy to get to work with that. And then once you're able to use those, or just observers, performance observer API, or the mark and measure, you kind of can just put them into like any application, Node application you want. Like you can make it work with Fastify, or like the one I work on is Mary, but either or. Like you can just put that in your application and kind of start seeing how you can work with those. But kind of the things I wanted to talk about is that, okay, so I was playing around with these, and I wanted to do quite a bit of like storytelling with performance observers, but what I ended up finding out is that it's mark and measure is super useful to be able to figure out like how long something takes in your application, and it's useful for debugging like development purposes. But it doesn't actually build like a narrative properly, because you're not able to kind of put anything together, and you want to be able to have a story, and you want to be able to put a trace together, and you want to be able to kind of chain things, and that's a little bit harder with observables. So I found that it's like it's definitely a development thing, a development environment thing, to be able to kind of predict that before you deploy to production kind of thing. So building narrative is hard, but the thing that I found is that, okay, so I want to be able to build narrative, and the API that I like for that is actually async hooks. And this talk was not meant to be about async hooks, but I wanted to briefly mention them as well. So with that, with async hooks, I think I'm able to build an actual proper kind of trackable narrative that I want to be able to see in my application code. And because performance observers kind of add, and performance API adds a bit of an overhead in your application, async hooks are much less so, and plus they add a little bit of a narrative to it. So you gotta kind of balance those out as to what is, you gotta cost it out like as to what you want. But like I said, I didn't want this talk to be on async hooks, so I'm just briefly mentioning them. And there's like a talk that Thorsten Lorenz did at Node.Conf.Asia about them, and he's done a bunch of work with them, and it's like really good. And I also wrote a little guide for them as well, if you want to look into that. And there's like a module that actually helps you create traceable events that you can specifically listen to and build a better narrative. So kind of wrapping up as to what we talked about. So we talked about the performance timeline. We talked about being able to look at the timeline and see kind of what performance entries we can look at and what kind of useful information we can derive from them. So that. We also talked about the specific mark and measure and using those to be able to debug certain parts of our application and work with those parts of our applications. And we also talked about the fact that once we're able to get all of our entries in one place, we're able to see and compare what exactly that they do in our application using the performance observer portion of the API. Yeah, so that was the talk I wanted to give. I am really happy that you were able to have me. I hope you enjoyed it, and if you have any more questions, come say hi on Twitter or just come say hi. Yeah, thank you.